Good morning, Prep 3. Today we'll study Lesson 2, the relation between the inscribed and central angles subtended by the same arc. We studied before the meaning of central angles, which is the angle, its vertex is the center of the circle, and its two sides are the two radii in the circle. What about the inscribed angle? The inscribed angle, it's the angle whose vertex lies on the circle and its sides contains two chords of the circle. So, angle ABC, its vertex B lie on the circle and its two sides BA and BC are two chords of the circle. So the difference between the central angle and inscribed angle, the central angle, its vertex is the center of the circle and its two sides are two radii. But the inscribed angle, its vertex is the point lie on the circle and its two sides are two chords of the circle. So the angle ABC is an inscribed angle because its vertex B belongs to the circle M and its sides BA and BC carry the two chords BA and BC in the circle M and also subtended by the arc AC. The arc, the starting letter and the ending letter. So the angle ABC, the vertex B, and the arc is AC. Okay, our lesson today is to studying the relation between the inscribed angle and the central angle which subtend the same arc. Theorem 1. The measure of the inscribed angle is half the measure of the central angle subtended the same arc. So if I have an inscribed and central angle subtended the same arc, so the measure of the inscribed angle equals half the measure of the central angle. And my condition is the two angles subtend the same arc. Okay, let's go to the example 1. M is a circle. In your booklet, page 96, M is a circle in each of the following find. Find Y if measure of angle AMB, if the vertex is the center of the circle, so this angle is a central angle. If the vertex is just point on the circle, so the angle is inscribed angle. Okay, he give me the angle AMB which equal Y plus 10, this is Y plus 10, and measure of angle C 40 degree. What is the relation between the angle AMB and the angle ACB? Yes, angle AMB is central angle subtend the arc AB and angle ACB is inscribed angle subtend arc AB. So the measure of the inscribed equal half the measure of the subtended of the central angle. He gave me the measure of the inscribed, which is 40 degree. So the measure of the central will be 80 degree. Then y plus 10 equal 80 and y equal 70 degree. Number 2, I want to find the value of x. The value of x. X here represents the inscribed angle ACB. Inscribed angle ACB subtend with the reflex angle, x plus 135, this arc. Okay? Then x here, the measure of x here equal half the measure of this reflex central angle. This is the central angle and this is the reflex center angle. So X here and the reflex central angle subtend the major arc AB. So X here equal half X plus 135. This number in your booklet is 35. Please write 135. So we will solve it as equation X equal half open bracket X plus 135. So X equal half X plus 135 over 2. I multiply half by X and half time 135. Then half X will go to the other side in minus. X minus half X equal half X equal 135 over 2. Then X equal 135. Now go to page 97. Example 2. CD is a tangent to the circle C, to the circle at C. CD parallel to AB. CD parallel to AB. If I have two parallel lines, then yes, the measure of the arcs between them are equal in measure. Measure of the angle AMB. Angle AMB is a central angle because its vertex is the center of the circle. Okay, prove that triangle CAB is an equilateral triangle. First, he gave me the measure of the central angle AMB, and I have an inscribed angle ACB. The central and the inscribed subtend the same arc AB. Then measure of the angle ACB equal half measure of the angle AMB. The measure of the angle AMB equal 120 degree, so measure of the angle ACB equal 60 degree. So this angle is 60 degree. And since CD parallel to AB, therefore measure of the arc AC equal measure of the arc BC. And if the measure of the arcs are equal, then the length of their chords are equal from the previous lesson. So if AC, measure of the arc AC equal measure of the arc BC, then the length of the chord AC equal the length of the chord BC. And the triangle will be isosceles, this is 60. So each angle of them will be 180 minus 60 over 2 equals 60. So angle C equals 60 degree, angle CAB equals 60 degree, angle CBA equals 60 degree, and the triangle is an equilateral triangle. The last example, AB is a chord and CM parallel to AB. CM parallel to AB. BC intersect AM equal E. So if I have intersection here, yes, between the two lines BC and AM, prove that BE greater than AE. We studied the inequality of length of the side of a triangle in Prep 2. If I have side greater than side, I have to prove that the opposite angle for this side is greater than the opposite angle for that side. Okay, let's see the proof together. I have here an inscribed angle ABC, ABC, subtend the arc AC, and central angle AMC subtend the same arc. So measure of the angle ABC equal half measure of the angle AMC. Okay? So measure of the angle ABC, this angle, half measure of the angle AMC. And since CM parallel to AB and MA is transversal, therefore measure of the angle CMA equal measure of the angle MAB, this alternate angle. So this angle equal that. And this angle half this. So angle B is half angle A. From 1 and 2, measure of angle MAB greater than or twice measure of the angle ABC. So angle MAB, I want to compare between the two lengths of the two sides BE and AE. If I want to compare between the lengths of two sides, I have to see or to put these two sides in one triangle, which is ABE. So measure of the angle MAB greater than measure of the angle ABE. The side BE is opposite to the angle A, and the side AE is opposite to the angle B. So therefore BE is greater than AE. Okay, that was our lesson today. See you next time.